Since the atmosphere and oceans evolved in the early Earth 4 billion years ago, the climate has always been changing. But over the past 150 years or so, the global average temperature has risen at a rate never previously observed. This global warming is a result of the increasing amounts of carbon dioxide and some other gases, including methane, being emitted into the atmosphere by human industrial and agricultural activities. Carbon dioxide concentrations have varied in the past, but the current value is the highest for at least 3 million years, before there were primates on Earth and long before the emergence of humans around 200,000 years ago. We know this extra CO2 comes mainly from the combustion of fossil fuels, coal, oil and gas, because it can be carbon dated as very old, and we understand the basic physical mechanism of how it heats the Earth's climate, known as the greenhouse effect. Its effects are not limited to raising the global temperature, however. Associated consequences include rising sea levels and melting glaciers, and the impacts are not distributed evenly over the globe. Land areas, especially those at high latitudes, are warming fastest. The effect on precipitation is also very non-uniform, with areas like South Africa and the Mediterranean becoming drier, while the rainfall of the India summer monsoon is becoming more intense. Indeed, it's expected that weather events that are currently seldom, like heat waves and droughts, or heavy rainfall and flooding, will become increasingly common. Along with coastal inundation and river flooding, this will make certain regions unfit for agriculture or even for habitation. As long as we keep putting CO2 into the atmosphere, global warming and all its associated impacts will continue. Recognising this, the United Nations Framework Convention on Climate Change, at its meeting in Paris 2015, reached a unanimous agreement that the global temperature rise should be kept this century to less than 2 degrees centigrade above pre-industrial, and to drive efforts to keep it below 1.5 degrees. Given that the 1 degree mark has already been passed, this implies a huge international effort needed to decarbonise. Most CO2 emissions come from burning fossil fuels for electricity, heat and transport, so we need to consider how we may source our increasing energy needs through low carbon methods. A major effort must be on energy efficiency, just using less, through, for example, insulating homes or changing modes of transport. There are many low-carbon technologies already available and being implemented. Renewable energy sources such as solar panels and wind turbines are beginning to play a more significant role. But the best solution for any location depends on the local conditions, including the climate, the availability of electricity grids and storage, indigenous fuels, or the availability of finance. Decarbonising the energy supply is hugely demanding, but it can be done.